Hello everyone. I would like to demonstrate just a bit of Euclid's Elements, Book 1, Proposition 1. I will be translating the Greek and talking to a bit of the math and geometry behind it. This is ideally a presentation for people who are learning Greek but also are interested in math. So let's get started. Um, the first section I wanted to point out is this introduction. I won't be using the Greek names for this in this video, but maybe in a later video I can talk a bit more about some of the structure and context of the propositions. Um, but for the first part, I'll read the Greek and then we'll move on and translate. So, epi tes dotheses eutheos peparasmenes trigonon isopluron sustesathai. On the given straight line, finitely bounded, to construct from sunastemi an equilateral triangle, a triangle with equal sides. And then the next section is esto he dothesa euthea peparasmene he alpha beta. So let there be, this is the third singular imperative from Amy. And then what we've seen already before, but the feminine singular aorist passive participle from didomi. Um, so let there be and this is a bit of the interesting part of Greek syntax, the given thing, which is straight, which is bounded, that is AB. So the line AB, which is given straight and bounded, which is in the drawing here, AB. So I'll just draw over that just to make that clear as we go. So now for the next part, we have de epites AB eutheos trigonon isopluron sustesas thai. So therefore, it is necessary, or it is required, to construct an equilateral triangle upon the straight line AB. So there's our introduction. Now we move into the key part of the proof here. Kintro alpha diastemati deto alpha beta kuklos ge graftho ha beta gamma delta. Kai polling kintro beta diastemati deto beta alpha kuklos ge graftho ha alpha gamma epsilon. Kai apo tu gamma semeu kata temnusin alelus hoi kukloi. Epita alpha beta semea epixeoktoson euthei hi gamma alpha gamma beta. So this part of the proof is saying, on the one hand, in the center, alpha, at a distance to alpha beta, the circle, let it have been written beta alpha delta, beta gamma delta. So this is the literal translation from the Greek word order. But a couple things to point out that's kind of interesting about this that you don't see too commonly. Gegraphtho, or you don't see too commonly outside of Euclid, is the perfect passive imperative from grapho. And we'll see in other propositions this syntax, this form is well used quite a lot. Um, but yeah, the perfect imperative, perfect passive imperative. let the circle, so now we're talking about beta gamma delta, let it have been written, or let it have been drawn, with center alpha and with distance alpha beta. So diastema right here is distance, but in this context, I think it's referring to the radius of the circle, so alpha beta. And then the next part is very similar. Kai pollen kentro mento beta diastemati deto beta alpha kuglas gegraphtho alpha gamma epsilon. So we have, and again, let the circle alpha gamma epsilon have been drawn with the center beta at a distance or radius beta alpha. So now we're talking about this part right here. Kai apo tu gamma semeu. And from the point gamma, so semeion is point, from the definition, which I won't go into too deep right here, um, according to which the circles cut themselves. So literally cut, but the idea is that these two circles intersect here. So we're just referring to this point right here. Um, let let the straight lines gamma alpha and gamma beta be joined epixoxon. So from sorry, it's a little hard to say. Zognumi. Let them be joined to each other. And that is the third plural imperative, passive imperative, um, upon the points alpha beta. So we're creating lines now. So we have a triangle created from the point gamma and from the two radii alpha beta and beta alpha. So now in the second part of the proof we have kai epe ta alpha semeion kentron sd 2 gamma delta beta kuklu ise estin he alpha gamma te alpha beta. So chi is chi epe, and since the point alpha is at the center of the circle gamma delta beta, so alpha is the center of our circle here that we pointed out, equal it is the line alpha gamma to alpha beta. So basically this is just pointing out the fact that gamma alpha is also a radius to the same circle, so they're equal. And then pollen again, so we use pollen a lot to say similarly, because it's effectively the same argument, just with the different variables replaced. So similarly, also this point beta is the center of gamma alpha epsilon of the circle, and the beta gamma is equal to beta alpha. So same argument for the other circle to the right. So edecthe decai he gamma alpha te alpha beta ise. So it has been shown from Deknumi, from Decomai, it has been demonstrated, the aorist passive, indicative, third singular. Also, the gamma alpha is equal to alpha beta. Gamma alpha is equal to alpha beta. So this is just pointing out the fact that we have already shown the fact that they're equal to each other. Hecatera ara ton gamma alpha gamma beta te alpha beta sd ise. And then we have our connector here, ara. And then, or thus, each of the two, gamma alpha and gamma beta, are equal to alpha beta. So we have both of those lines are equal to alpha beta. And then we have our presumptive conclusion here from definition, or I'm sorry, from common notion 1, which I've just linked down here, but we also have it repeated here. Ta de to auto isa, kai alelois estin isa. So literally, the things to themselves being equal to one another are equal. So the neuter plurals in Greek do this thing where they can have singular verbs. So that's something to get used to if you're not familiar with that. But the idea that is effectively saying that since the things which are equal to one another are equal to themselves, so they're the same thing, the same length. Kai he gamma alpha ara te gamma beta estin ise. Hai trace ara hai gamma alpha alpha beta beta gamma isai alelais esin. And then we have another ara here, so, and therefore gamma alpha, this line, is equal to gamma beta. And the three, gamma alpha, alpha beta, beta gamma, are equal to each other. So we're just pointing out that this is, in fact, an equilateral triangle. Therefore, the triangle alpha beta gamma is isopleuron, it is equilateral, and it has been constructed upon the given finite straight line alpha beta. So we had our straight line here, and we've shown that the triangle at the intersection of these two circles, gamma, is an equilateral triangle. Epites deltheses ara euseas peparasmenes trigonon isopleuron sunestatai, haper ede poiesai. So this concluding section is just repeating similar things. Upon the given straight line that is finite, an equilateral triangle has been constructed. Haper ede poiesai. So, which is the very thing it was necessary to do. So this is effectively our QED, end of proof. So thank you for watching. I hope this helped you understand a little bit more about Euclid and hopefully help you understand a bit of the Greek as well. So hope you enjoy, and thank you. Have a nice day.